Hi class and welcome to section 6. Today we're going to be talking about exponents. We're really worried about if you know when to add them, when to subtract them, when you multiply them, and when you move them. So let's see how you're doing. All right, when you go here, so we're going to simplify exponents and we're going to worry about simplifying expressions with rational exponents or exponents that are fractions. First thing to remember, if anything to the 0 power is equal to 1, and if you have a negative exponent, it's in the wrong place. So if it's in the numerator, it belongs in the denominator. But if it was in the denominator, then it would move to the numerator. All right, remember when you multiply like bases, you add exponents. When you divide like bases, you subtract the numerator exponent from the denominator exponent. When you take a power to a power, you multiply them. Distribution works the same in multiplication or division. You distribute the exponent to everything that's inside. So both terms, the A and the B. All right, let's see if you remember. So I'd like you to pause and try the ones that you have on your paper. And it should not take you very long. Please do not find the actual answer. I just want you to work with the exponents. Okay, your first one you should have had. Hey, I'm multiplying like bases, add the exponent. So that's 7 to the 10th. You're dividing, so you subtract. So that's 9 to the 8th. Dividing again, so you subtract. I'm hoping you did this one step and realized the larger number is in the bottom, or the denominator, so your r is in the denominator, which is 1 over r to the 8th. If you actually subtracted and did 9 minus 17, you would have gotten r to the negative 8th, realizing that's in the wrong place, so you would have put that r to the 8th in the bottom. Both ways are correct. The 4 you should have distributed through. I actually don't care right now. So that should have been 2 to the 4th and x to the 12th. If you multiplied the 2 out, that's great. If you did not, that is okay too. Here you had a couple of ways of doing that. You could have distributed the 6 first, which would have given you x to the 12th and y to the negative 18th, and then move the y up, which would give you x to the 12th, y to the 18th for your final answer. If you recognize this negative and moved it up first, you would have just added x squared y cubed and then distributed your 6. Both ways you would have gotten to the same answer. Here, there's a couple of ways to do this. I'm going to do it where you work with the inside of the parentheses first. So let's look at these a's. I got a negative 3 on the top and a 4 on the bottom, which means these negative 3 need to move down. So I really have a to the 7th in the denominator. And this b to the negative 7th needs to move up, so that's b to the 13th. Okay, I got some stuff in the way here. Let's get rid of a little bit of this. All right, so now when we're looking at this, I still have to deal with this negative 2 on the outside. A couple of ways to do that also. I could switch and make that a positive 2 and then distribute, or distribute and then move them. I'm going to distribute first. So this gives you b to the negative 26 over a to the negative 14th, because you're distributing this negative 2 to both exponents. Both exponents are negative, so they are both in the wrong place, which means the a belongs in the numerator and the b belongs in the denominator. A little bit of work, but not bad. This last one also has a couple of ways to do it. That's supposed to be a division sign. I hope you recognize that. It kind of looks like an addition. So this is really 1 over x divided by 1 over y squared. Well, when you divide, you multiply by the reciprocal. So that's 1 over x times y squared over 1. When you multiply fractions, you multiply straight across, which gives you y squared over x. Okay, there were other ways to do this. You could have also have said, and I'll do this over here, this is x to the negative first over y to the negative second, realizing they're both in the wrong place, and flip them, also giving you the exact same answer. Hope you did a great job. Okay, on to the next page. All right, when we're going here, this is rational exponents, and we're dealing with numerators and the denominators. I am going to show you the old way you learned how to do this, just in case you get lost, because you're not allowed to use a calculator on this one. So this means I'm looking for the 1/6 of 64, which means I'm looking for groups of 6. I need 6 things that equal a whole. So when you do that, you're looking for 6 same numbers and 64. And you learned to do this with a factor tree when you were little. So you could do all 2's, or you could say, hey, 64 is 8 times 8. Then 8 is 2 times 4. Well, 4 is still 2 times 2. Now I'm all down to prime numbers here. And I have 6 2's. 1, 2, 3, 4, 5, 6. So it takes 6 2's to make 64, which means the 6th root of 64 is equal to 2, because this is technically 2 to the 6th power to the 1/6 power. Well, 6 times 1/6 is 1. All right, try yours. Okay, 256. I usually start with 2. This is 2 and 128. 2 and 64. 2 and 32. 2 and 16. 2, 8. 2, 4. 2 and 2. I am looking for groups of 4. Well, when you look at this, this is really 2 to the 8th to the 1/4 power. Well, 8 times 1/4 is 2. When you multiply these two, right? That's 2, so that's 2 squared, which is 4. Or 2 groups of 4, either way. Okay, now let's look at this one. Now again, we've got all these negative exponents to deal with, so this -5 needs to move up first. So that's m to the 12th power. Whoops, positive. And this is n, this 2 needs to move down, so that's n to the 4th. You are taking the 4th root of both. So you're technically, I'm going to get rid of some of these 2's over here. Technically, you're saying this is m to the 12th power times 1/4. So 1/4 of 12 is m cubed. Right, now let's work with our denominator. So that's n to the 4th times the 1/4 power, or to the 1/4 power. So 4 times 1/4 is 1. So it's m cubed over n. Kind of fun, huh? I like these. All right, now let's look at your next problem. You could have done this pretty hard or pretty easy, depending on what you look at. I look at this numerator and say, hey, I can add those. 1/3 plus 5/3 is 6/3. So this is really y to the 6/3. I'll do it in 2 steps. You don't have to. Over y3. Well, 6/3 is 2. So this is y squared over y cubed. In division, I'm subtracting. So I have 2 in the top, 1 in the denominator, which is going to give me 1 over y. Okay, next section. This one here is a little bit more complicated, but you just got to be careful on what you're looking at. And you will use this a lot. So make sure you understand and ask questions in the discussion post if you need to. All right, you're looking here. This is one term and this is one term. You have to take out what they have in common. And remember, you always take out the lowest exponent. Well, x squared plus 5, I don't have one over here, so he's alone. But 3x minus 1, we have a -1/2 here and a +1/2 here. Well, the smallest between those two is a -1/2. So we're going to take out or divide by 3x minus 1 to the -1/2 power. All right, well, if I take the 3x minus 1 to the -1/2 here, it just cancels those two, right? Look what happens over here. 3x minus 1 to the -1/2. When I divide, I subtract exponents. So 1/2 minus a -1/2 is 1, right? So this right here becomes 3x minus 1. Just remembering, we're going to do that in a little bit here. Now, if we look here, I have a 2 in common on both of these, so I need to take that 2 out. So I'm going to divide by the 2, and he's going to be gone, and he's going to be gone. This actually became 3x minus 1 to the 1st power. Well, the 2 is going to cancel, but that x is going to stay. All right, I've got a little bit of mess here. So I'm going to put a bracket so I know what I'm left with. So on this term here, I am left with x squared plus 5. Not too bad. This term here, I'm left with 3x minus 1 times x. So I'm going to distribute that through, which says I have a 3x squared minus x left on this side. Now all I do is combine like terms. So my 2 stays out here. My 3x minus 1 to the negative 1/2 stays here. And then in the parentheses, I'm going to be left with 4x squared minus x plus 5. Well, this does not factor. I cannot take 4 and 5 and add them to get a negative 1. So this is done. If this factored, I would have to go farther. All right, your turn. What do they have in common? Pause and try. All right, the 5 and the 4 had nothing. I'm tired of red. And the z, I have a 1/3 and a negative 2/3. Remember, you always take out the smallest. Well, the smallest of these is z, the negative 2/3. So when I take out the z to the negative 2/3, 1/3 minus a negative 2/3. So this is what you're doing. 1/3, you're working with just the exponents, minus a negative 2/3, so that double negative makes a positive, is 1. So this means I am left with 5z in this term. Plus, while I'm taking out z to the negative 2/3 here, well, that just cancels, leaving me with a 4. There's nothing I can do with a 5z plus 4, so that is finished. It's kind of fun, isn't it? All right, it's homework time. I hope that makes up for yesterday being so long. Okay, have a great day and good luck.